So I'm redoing number 5 for this exam too, because this is the one I got the most wrong on. We'll start with part A. A small rabbit colony starts with 5 rabbits in month 0. Each month, every rabbit produces 2 new rabbits, and 3 rabbits leave. Rn plus 1 be the number of rabbits next month, and Rn the number of rabbits this month. Write a recurrence relation for the number of rabbits next month based on the number of rabbits this month. So if we start with 5 rabbits, each rabbit produces 2 new rabbits, right? So the original rabbit would be Rn, and then the next 2 rabbits would be 2Rn, right? So 1Rn plus 2Rn would be 3Rn. So we got 3Rn, and then we also got minus 3 because 3 rabbits leave the colony. So the recurrence relation for this would be Rn plus 1 equals 3 times Rn, so 3Rn minus 3. So that would be how you would tell. Let's see, that would be how you would tell the number of rabbits next month based on the number of rabbits this month. So now moving on to part B, consider the following recurrence relation: a of n plus 1 is equal to 1.2 a of n, and a of 0 is equal to 5. Using the method of iteration, find a solution for this relation. So I was showing the video and how we solve it. We start with the 2 values, right? So we start with a of n plus 1 is equal to 1.2 a of n, and then we also have a of 0 equal to 5, right? So a of 0 is our starting value. So a of 0 is 5, right? So we start a of 1, 1.2 to the first power, and then we do that so on, right? So we do 1.2 to the first, 1.2 to the second, 1.2 to the third, and so on and so forth until we reach our final value, which would be 5 times 1.2 to the t, or if we want to be really right, it could be to the n. So the way we use this method of iteration is basically by repeating the values. I'm not repeating the values, but applying the rule over and over. So we're basically iterating. We're plugging this in, and we're iterating each time to find out what the solution for this relation would be. So basically, we start with a of 0, which is equal to 5, and then we just take the 1.2 and we multiply by 1.2 each time until we see the pattern, and then when we see the pattern, we finally get this the 5 times 1.2 to the t, or 5 times 1.2 to the n. And finally, for part C, consider a relation represented by the following table values. So we start with 0, n equals 0, and our value would be 24, and then we go on 18, 10, and then 0. As you can see, from here, 24 to 18, that goes down by 6, and from 18 to 10, that goes down by 8. Right, so our constant value going down would be 2. That's how we got k equals 2 here. Right, I don't know, this might be k, but we're going down by 2 each time, and since our second differences are constant, we're going down by 2 each time, basically. That would prove that the relation represented by here, it would be quadratic. And finally, for the second part of C, it says, is this relation delta k, so yeah, delta k or delta square constant? If so, for what k, what type of regression model would be appropriate for the solution? Do not find the regression equation. So delta k constant. So what does this mean? So if this is constant, which it is going down constant, so it is quadratic. So is the relation delta k constant? That would be true. Our k would be 2, so delta squared. So it says what type of regression model would be appropriate for the solution. It would be a quadratic model, right? Because we've already proved that when it's going down by 2's, or here k equals 2, it is delta square constant, which is quadratic.